Hey everybody, I thought I would do a little video to help kind of think about that thought process as you're going through balancing equations and trying to do these ionic equations. So I chose to look at page 5 out of your A2 booklet. I know we've done it before and the answer key is up, but sometimes it helps to hear how to go about it. Okay, so I'm just going to work through some of these and start at the very basics when we started our first talk about ionic compounds. All right, so ionic compounds by definition are compounds that take a cation, which is an ion that has a positive charge, and we add it to, we chemically combine it, they give their electrons away to another element which is known as an anion. So anions are negative because they receive electrons, and that's how these compounds bond. That's how they come together, is they actually donate and accept an electron. So because of that, these previously known as atoms become charged. Okay, the metals are always going to be positive, and the non-metals are always going to be negative. Okay, and these are known as cations and anions. Now, the ratio that they bond in, the number of them that come together, always come together so that when they do come together, they have a zero charge. So they might start with that charge, their ion charge, but you will have to add to either side to get the positives to completely cancel out the negatives. Okay? Now, when we go forward talking about polyatomic ions or multivalent ions, it's going to be the same basic outcome. You want to get enough positives to balance the negatives. Okay? We are always putting together ions where there's two parts. So these are called binary. There's a positive and there's a negative. Bi means two, so these are binary compounds consisting of two parts. Now, if you see your compound has more than two capital letters, we'll look at it. We'll do another video about using polyatomic ions. Okay, these ones, I think on the whole sheet we'll only be using two capital letters, which means that they're straight elements. There's not going to be any groups. They're singles. Okay, so let's have a look at the first one. This one is calcium. Calcium's the positive, and chlorine, C(l), is the negative. Now, to actually know the charges, we need to constantly be flipping back to our periodic table. Okay, the knowledge of the periodic table becomes very important, and hopefully you're using it so much that it almost becomes second nature. Okay, everything in this column, our noble gases, has a charge of 0. Okay, all of these ones, let's say all of our metals, okay, these ones all have some sort of positive charge. Okay, these ones are all negative. They're not written how many charges they have on the negative, so what we'll do is we will just count the vertical columns away from the 0 noble gases. Okay, so that leaves us the the halogens, starting with fluorine, which has a -1 charge. All of them have a -1. They are 1 away from 0. All of the next row here, starting with oxygen down to tellurium, all have a -2 charge. And then the next one, the next column is -3. The next column, if we're using it as the second part of an element, the anion, the negative charge, would be -4. Okay, so that knowledge, we're picking something from over here and putting it with something over here. We have to add either more positives or more negatives to get them to cancel each other out. All right, so our compound that we're looking at is calcium. Calcium is found over here. Okay, everything in this row happens to be a +2. So calcium's charge is +2, and calcium was put with chlorine. Yes, which has a -1. So if we were going to put them together, we would write calcium with a 2+. We've got 2 positives, so we will need to have a total negative charge of 2. And so we will need to have 2 of these chlorine to get it. How we name it is always write the name of the first element first, don't change it, and then write the name of the second element, just the first part, we call it the stem, and then add IDE instead of its regular ending to the end. And it's done. Okay, so working back from the second question, we'll do this one. We've got iodine and potassium put together. Iodine is the negative, potassium is the cation. So if we go and look on the periodic table, we need to know their exact charges, and we need to find their symbols. Okay, let's erase a little bit here, clean it up. Okay, so potassium is right here. Okay, it's got a charge of +1. So that's our cation charge. And it was put with, short memory I have, iodine. Okay, and iodine, we find that on the periodic table. Iodine happens to be in with those halogens. And it's 1 away from the noble gases, so it has a -1 charge. So we've got a +1 and a -1. So the first thing you ask yourself is, by themselves, are they balanced? So if we write down their symbol, we put the cation first. There will also be an anion. So we write them down, and it looks like this one is just balanced perfectly in a 1-to-1 ratio. So I can write the elements symbols right there for its formula. All ionic compounds are solids. So at room temperature, we could go down and put little s's all the way down to the bottom. Oh, we don't have to look them up on any table or anything like that. All ionic compounds at room temperature are solids. So we'll do one more, going the other direction. So this one has 2 capital letters. Okay, the small letter G is part of the M, and O is by itself. So when we look them up, Mg and O. Mg, I know I'm looking left of the staircase because I'm looking for a positive. And Mg is found in group 2. Okay, so I see it here. Its charge is a +2. And it was put with oxygen, which is 1, 2 away from the end. And so it also is a -2. Nice, we've got 2 that actually cancel each other out just by themselves. So magnesium is a +2, oxygen is a -2, so I only need 1 of each as shown in its formula, and I write them as magnesium oxide. All right, we'll get into some little more difficult, challenging ones in another video. All right. Thanks. Work hard. Keep asking questions.